Hey guys, welcome back. We're going to continue solving radical equations, and this time we've got two radicals on the same side and a number over here as well. In order to solve this, it's going to be way easier if we take this radical and move it to the right side. This one in particular, because it's negative, but we only want one radical per side, and since this one's negative, move it over, make it positive. So we get 6x plus 12 square root equals 1 plus the square root of 4x plus 9. And now we can square both sides. A reminder, when you square a binomial, like a plus b squared, that means a plus b times a plus b. Every time you do that, you're going to get the first term times itself, first term squared, then AB and AB, so 2 times AB, which means just double the product of the two terms. And then you're going to get the last term times itself, B squared. And I really don't want to rewrite this as 1 plus that radical times 1 plus that radical. I want to go straight from here to here. On the left side, the radical is going to cancel. On the right side, a squared, that's the first term squared. 1 squared is 1. Double the product of the two terms. 1 times the radical doubled is 2 times the radical. And then b squared is 4x plus 9. Notice I still have a radical, and I'm going to have to get rid of that. So what I'm going to do is move everything to the left side except for the radical. 6x minus 4x is 2x. 12 minus 1 minus 9 is 2. We can make life a little simpler on ourselves by dividing both sides by 2 and get x plus 1 equals square root of 4x plus 9. And now square both sides. Again, first term squared is x squared. The product is 1 times x. Double that is 2 times x. And the second term squared is 1. And over here on the right side, the radical and the square root cancel, the squared and the square root cancel, 4x plus 9. Let's set this equal to 0. Move everything to the left. X squared minus 2x minus 8 equals 0. And then we can factor. Multiply to negative 8, add to negative 2. Two numbers that do that are 4 and negative 4 and 2. So x minus 4 times x plus 2 equals 0. So I get my solutions. So x equals 4 and negative 2. Okay, so I need to check those. Okay, 6 times 4 is 36, or 6 times 4 is 24, plus 12 is 36, square root is 6. 4 times 4 is 16, plus 9 is 25, square root is 5. 6 minus 5 equals 1. That is true, so 4 checks out. Now I'll check negative 2. Six times negative 2 is negative 12, plus 12 is 0, square root is 0. 4 times negative 2 is negative 8, plus 9 is 1. Square root of 1 is 1. 0 minus 1 does not equal 1, so I have to throw out that solution. X equals 4 is my valid solution. X equals negative 2 is an extraneous solution. In number 6, once again, I need to move one radical over. I'm going to move the negative radical. And just to work with positives, I'm going to move that negative 11. So I'll square both sides. First term squared is x minus 3. Product of the two is 11 times the radical. Double that is 22 times the radical. And the second term squared is 121. On the right side, I don't have a plus or a minus here, so I just squared the 3 and I squared the radical. 9 times x plus 12. Clean that up a little bit. Next thing I would do is distribute the 9. This side's not going to change, so I won't write it here again. I still have a radical here, so I'm going to take everything that's not the radical term and move it over. So 22 times the radical equals 9x minus x is 8x. 108 plus 3 is 111. Minus 121 is negative 10. Here's an opportunity to simplify things a little bit. I can divide everything by 2 just to work with some smaller numbers. Okay, now I need to square both sides again. And so when I square this side, I get 121 times x minus 3. And on this side, the first term squared is 16x squared. Double the product. The product is negative 20x. Doubled is negative 40x. And the second term squared is 25. Next thing I want to do is distribute. Okay, now I'll bring everything to the right side. 0 equals 16x squared minus 161x plus 388. So I added 121x to the negative 40x. So I'm sorry, I subtracted negative 120x from negative 40x, and I added 363 to 25. This does not look fun to factor or for completing the square, so I'm going to use the quadratic formula. X equals opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, so negative 161 squared minus 4 times 16 times 388 is 1089, which happens to be a square number. The square root of 1089 is 33. So x is 161 plus or minus 33 over 32. 161 plus 33 divided by 32. If I just type that in my calculator and ask for it as a fraction, I'm going to get x equals 97/16. And if I do 161 minus 33 divided by 32, I'm going to get 4. So those are the two solutions that I need to check. So back to the original equation, 97 sixteenths minus 3 under a square root minus 3 times the square root of 97 sixteenths plus 12 should equal 11. So if I just type all of that into my calculator, that should actually equal negative 11. Let's fix that. If I type all this in my calculator, it will give me negative 11. So 97 sixteenths checks out. And then I do the same with 4. And if I type this into my calculator, it does give me negative 11, so 4 also checks out. So both solutions are valid. Number 7, all of my, I only have one radical that's on one side, so I'm ready to square both sides. First term squared plus double the product of these, so it's 10x doubled plus the second term squared equals x squared minus 2x plus 1. Okay, we'll move everything to the left, so I have a positive lead coefficient. 4x squared minus x squared. $20x plus 2x. And 25 minus 1. This one won't be too bad to factor. So I need two numbers that multiply to 24 times 3, which is 72, and that add to 22. The numbers that do that are 4 and 18. So we'll use a box to factor. 3x squared, first term. Last term is 24. And 22x gets split into 4x and 18x in either order. So out of this, I can factor a 6. Here I can factor an x. Here I can factor out a 3 and an x. And here I can factor out a 4. 3x plus 4 times x plus 6 equals 0 is my factored form. If I set this equal to 0, move that over, I'm going to get negative 4, and divide, I'm going to get x equals negative 4 thirds. Here, I'm going to get negative 6. So those are my two solutions that I need to check. So 5 plus 2 times negative 4 thirds should equal the square root of negative 4 thirds squared minus 2 times negative 4 thirds plus 1. Right, now if I just type this into my calculator here, I'm going to get 7 thirds and 7 thirds. So negative 4 thirds checks out. If I plug in negative 6, 5 plus 2 times negative 6 equals the square root of negative 6 squared minus 2 times negative 6 plus 1. If I type both sides of that into my calculator, I'm going to find negative 7 equals 7. And that is not true. So negative 6 is an extraneous solution. Then on number 8, we'll square both sides. First term squared. The product is negative 3 times the radical. Doubled is negative 6 times the radical. And the last term squared is plus r plus 1. Okay, I need to move everything except the radical term over. Okay, so I've got 4 minus 1 minus 9. So that's 4 minus 10 is negative 6. Negative r minus r is negative 2r. Square both sides again. 36 times r plus 1 equals first term squared. The product is 12r, double that is 24r. And then the last term squared is plus 4r squared. Distribute. And then we'll move everything to the right side and simplify in descending power, in order of descending power. So equals 4r squared. 24r minus 36r is negative 12r. And 36 minus 36 is 0. So this is it. I could divide everything by 4. I can factor out an r. And now I can get my two solutions. The value of r that makes this factor a 0 is 0. The value of r that makes this factor 0 is 3. So I need to check a 0 and a 3. 3 minus square root of 0 plus 1 should equal square root of 4 minus 0. 3 minus 1 is 2. Square root of 4 is 2. 0 checks out. 3 minus the square root of 3 plus 1 should equal square root of 4 minus 3. 3 minus the square root of 4, 3 minus 2 is 1. And the square root of 1 is 1. That solution checks out. Both of my solutions are valid.